Hello everyone, this is a video to guide you through the way to resolve the question 4 of test 1 of the for 2014 Physics 2212 at Georgia Tech. So basically, I'm pretty sure you already read the actual problem, and this is what you have to do first. First, you have to draw exactly what situation is going on, and the most important thing is to know where to put first your angle, and look at it that way. Usually, like the first time I did it, I didn't get it right, and I choose my angle going from X going down to this situation here. But that was a mistake, because if you look at it that way, you never start a problem with an angle that is in the middle of something. So the most important thing is first to choose the angle theta, and here is the best way to put theta. And if you consider theta being here, you see that theta is going to move from 0 to pi, and this is going to really help you later in question B. So first, when after choosing theta, you can then look for the actual what is the formula dq. If this is a rod that is bent, what is the actual charge on dq? And the actual charge on dq is gonna come from the operation here. So you have dq is equal to dl times q over l. If you're not following, dl is gonna be this little change here, and q over l is gonna be this old rod here divided by q. So q over l will give us one small little charge, one small little displacement here that will be about like the represented, like the evenly distributed charge on the whole rod. And if we want that exactly, we will have to multiply by dl, and this is the dl here. And dl is going to be equal to r multiplied by theta, by d theta, meaning the difference, like the change in d theta that is here. D theta is here, and if theta is changing from here to here, times r, we'll have like the displacement here, basic formula. So basically from there, dq is equal to q, the whole charge, multiplied by d theta over pi, because first, like from over here, you have L equal pi r. So Q over divided by pi r. All the way here, you have dq is equal to Q divided by d by Q. So you have dq is equal to Q divided by pi d theta. Then the second most important thing to do is to actually find r. And with the right angle, we find the right r, which is the one given here. So r is equal to negative sine theta, negative r sine theta, r cosine theta, 0. With that, you can find the unit vector r hat, and then start resolving the problem. And first, the problem is asking you to find dE. dE is going to be basically the electric field because of this charge dq here. So dE is going to be basically your k, 1 over 4 pi E0 dq over r squared multiplied by r hat. R hat will be basically sine theta and negative cosine theta. Why? Because the magnitude, r divided by its magnitude, and if you have the formula in mind, that's cosine squared plus sine squared is equal to 1, you're just going to end up here. So for question 1, after you actually find the r hat, just plugging in dq here, you basically have like that dE is equal to k dq multiply dE is equal to 1 over basically your k multiplied by q d theta over pi r squared multiplied by your r hat, and this is your first answer. This is the resume of everything you have to do. This is the main important ideas that you have to consider to actually resolve the first part, and it's self-explanatory. This is just the formula with what you found over here plugged in. And this is question A. For question B, you just have to again use the formula that if you have dE to find E, you just have to integrate dE. So and again, one important thing in choosing the angle is that you have to realize that choosing from 0 to pi here helps you a lot here, because this is going to be your integration variables. So basically here E is equal to integral from 0 to pi of the dE that you found in question A. From there, then you just integrate the actual values in the r hat, because they are the only one that will change, considering that you're integrating with respect to d theta. Those are the only theta that exist in the equation. So integrating, the y values will tend to 0, because the integral of cosine will give sine, and sine of 0 or sine of pi are both 0. So the y values will be 0. The z values are already 0, because it's the integral of 0 that is 0. And the main focus is going to be here, the integral of negative cosine theta from 0 to pi. If you do the equation, you're going to find that here you get negative 1 minus 1 minus 1, which is negative 2, which is plus 2, I'm sorry, plus 2. So negative 1 minus 1 is negative 2, and the minus outside here gives us 2. So at the end of the actual integral here, just intuitively, if you have a rod that is bent like that, and all of the charges are pushing that way, in some sense you know that the actual E from the whole rod is going to go on X. And basically this is what we found here. At the end of the integral, only X values exist and are positive, and 0 is 0 for Y, 0 for Z, and that's all you need. Your E is going to be equal to what you find here, so the multiplication of here and the integral that you found here, so 2q over 4 pi squared epsilon 0 r squared 0 0, and this is your vector. And that's all you need to actually, this is the answer for the second question. And for question C, it's self-explanatory. If one side is positive and the other side is negative, if you go far enough, it becomes a dipole, a positive and negative end. And if you remember the diagrams used to find the direction of the electric field of the dipole, you just use this formula on this graph, and then you're just basically gonna know where the electric field is gonna be. This is where the electric field is gonna be, where's gonna be the direction of the electric field, and basically that's all you need to finish the test. And I hope this actually helped in any way, and thank you for watching. Thank you.